folks. Welcome out there this afternoon. A great Friday afternoon for specialized segments and a chance for you to sit back, relax. We'll do some math. I'm Ernie Roberts. I'm your host for this afternoon's version of TNLearn Mathline. And it's a day of specialized segments. We got a great topic to discover in depth together. So get you some paper, get you some pencil. I don't think you're going to need a calculator today, but, for those of you who kind of feel a little like you like to have it around, go for it, all right? But anyway, we're going to do some math here in just a moment. Let's see what our topic is for today. What we got going on, guys? We got here. For specialized segments today, is all things in mathematics are not created equal. Not created equal. We're talking inequalities today, and we're going to solve inequalities. Now, last week we just touched a little bit of the base of it. We learned how to operate with addition, subtraction, multiplication, division. We learned that you have to be very, very careful with multiplication, division, watching for those sign changes and for the shift of the inequality when you divide by a negative, all right? But we're going to look back at some things today. We're going to move forward. We're going to make these stretch out a little bit more. But you know what? If you can do equations, inequalities are a breeze. All you got to worry about is that little negative division or negative multiplication situation. All right, so let's see what we got. Our first problem is solve the inequality and graph the solution on the number line. And notice here we got a little bit more advanced, but still rather reasonable. If that had been equals, you all been just all over that thing. And since it says greater than, you can still be all over that thing, all right? So let's see. We're going to take 2x. I'm going to rewrite it here so you guys have a chance to do it at home also. Greater than 9, all right? And we'll use this for our number line here in just a minute, all right? The graph there, that's what that's sitting there for. It's for us to graph. Nothing spectacular, just what we're going to do with it. So here we go. We rewrite a problem, and you all have it down over there at home, I hope. And we're going to do very similar to what we do with equations. We're going to add 3 to remove a minus 3. And when we do it to the left, we got to do it to the right. Our good old friend, the addition property of not equality this time, but inequality, all right? So let's do so. We'll add 3 to both sides, and I have 2x greater than 12. Hopefully you guys have the same thing over there. Now, it's easy. We've just got to multiply by half or divide by 2, however you want to look at removing this 2. I like to divide. So here we go. We'll take 2 into both of those, and that's going to leave us with x greater than 6. Now notice, you said, what does that have to do with Ernie? That greater than, what are we going to do with that? We're looking for numbers that are bigger than 6. So on the number line up here, I'm going to find a place that we're going to call 6. Put it right there. And we're going to have an open circle at that point. And remember, we don't want to include 6. We would have had equals to underneath there. It's just it's open circle. And since it's greater than, we are looking for numbers that work out to the right, and we'll just kind of darken that arrow a little bit there, going that way. So we know that's the way it works. A quick check, certainly we can do that. How about the number 7? 2 times 7 is 14, minus 3, that's 11. Certainly 11 is greater than 9. So it's easy to check, pick a number that's in this shaded region, and if it works, you've got the good solution, all right? So simple, straightforward, very good to get started with you guys, all right? So now you're with me? Let's see, you stay with me here. Let's go backwards just a little bit here. Let's take a look at our next problem here. It says 23 greater than x plus 25. Now, a lot of times we just get nervous. I know I used to when I was younger. I've gotten used to it now. But when that x appears on the right side, we get a little bit, oh, what do we do? What do we do? Well, we're still going to work it like we wanted to. We want to get x by itself. All right, so let's do the first thing. We're going to need to remove that 25. So this time we're going to subtract 25 from both sides. And it is going to give us just what we're looking for here. Gives us x, all right? We've still got this greater than symbol pointing there. And over here now, remember what 23 minus 25 is going to do. It's going to give us negative 2. Now, we look at that. We look at that problem a little bit. And you know what I like about that is I have to be careful. So many times we say, oh, we see greater than, we're going to shade to the right. But what has to happen is we have to have our variable, x, y, whatever it happens to be, needs to be on the left before we start going with this greater than going to the right, if that makes sense to you. So what we're going to do, we're going to just simply switch the order here. It's not going to change the inequality. Not going to change it at all right? And we're going to make this become x less than negative 2, all right? So we'll find negative 2 somewhere on this last little number line here. There, it looks like a good place for it. We'll put an open circle. And this time we're going for less than. So we'll darken it this way, and we'll shade it back up to that point. a quick check. If we put a negative 3 in there, for example, negative 3 would be a good answer, right? So we put negative 3 plus 25, we're going to get 22. And folks, 23 is greater than 22. So that's why you have to be careful when you do the switch here. Make sure you got that X on the right before you decide where you're going to shade, all right? Make sure you got that X on the left, excuse me, before you decide which way you're going to shade. And that way, won't have any problems there, okay? Now, that's our kind of opening and such there. You wonder, well, Ernie, does it worry about if we have multiplication going our way? Well, let's check and see one real quick. This one says 16 times y, and over here we have negative 8. And once again, we got that greater than symbol in there, kind of messing with us a little bit. So again, we want y by itself. We're going to divide both sides because we're hooked in by multiplication here. All right, everybody with me there? So we're going to do 16 to both sides of these. And it looks like I'm going to have a negative 8 over 16. That'll reduce. Let's reduce that. Goes down to a negative 1/2. And we're going to end up with y here. All right. Now, you say, Ernie, when do we ever shift the inequality? Well, we're going to shift just because we're going to put y first here. All right. That's another story. When we divide by, if there'd been a negative there, we would really be having to think hard on this one. All right. But there isn't. There isn't here. So we're going to go ahead and say now that y is less than the negative 1/2. So spot negative 1/2 somewhere. And let's see what we got here. There's a good place for it right there. Open the circle because we're not including it here. And this time we're shading. Again, we're going to shade it off to the left. Put a quick negative 1 in there for y. Put a negative 1 in there. So put a negative 1 in there. That's going to give me negative 16 and negative 8. Now, some of you go like, well, negative 16 is bigger than negative 8. No, it isn't. No, it isn't. Negative 8, remember, is greater than negative 16. So that negative 1 did check. So we are in the right place on this one. We're on the right place. So that's another way that you can make sure, did you get the signs going in the right direction? Take a look at what you graph and then go back and check, substitute. Great way to finish off your problem, okay? And like I said, great way to fix yourself from having a careless mistake of some sort. Now, let's look at this next one here. It's got a little different twist. This is actually getting us more to what I want to do today. It's going to get us to these more than one step problems, all right? We got 4 minus 40 over here. Let's go ahead and do that. Folks, that's going to give us a negative 36 right there, greater than a negative 9x. Now, must be careful here. This is that situation I was warning you about at the beginning of the show in the last problem. When we divide or multiply by a negative number, we're not going to only just change signs, we are also going to shift the inequality, okay? And when we do that, we're going to divide both sides here by this negative 9. Right there it goes. That's going to leave us with 4, and it's going to leave us with x. But remember what I said, we divided through by a negative, so we have to switch. We have to pull a switcheroo there. And you know what that does? That translates us to getting x greater than 4. Now you say, is that good? Well, let's check and see. Let's use our graph. Let's use our graph. So we'll find a point here, call it 4. It is an open circle situation. We haven't had an equals to up there yet, but we'll get there. We'll see some of those, I'm sure. And according to this one, it says it's going to be greater than 4. So we're going to shade off this direction. And you say, well, that got you back where you started from. Exactly. We had to do 2 shifts, okay, to get the x to the left and also to get the sign change. And let's see if that worked. See if that worked. We put a 5 right up here. A 5 is going to give me, well, this is going to be negative 36. And a 5 over here is going to give me negative 45. And folks, negative 36 is bigger than negative 45. So we did get it going in the right direction in the end. Again, be careful. Be careful on those shifting signs, all right? Those shifting directions of the inequality. They are essential and important when you divide or multiply through by a negative. All right, let's take a look at our next problem here. It gets a little more advanced here. Let me rewrite this one for us. And by the way, this is going to be our number line this time. Kind of moved up a little bit. We'll come back and fill it in there. But let's take negative 2x, and I'm going to put over a big 3 there, all right? And we're going to add 10, and then it's going to be greater than 16. Let you all get that copied down at home. And again, we don't have an equals to yet. We're going to get back to those here. We'll pick up one of those. If not, I'll create one. How's that? Now, let's remove our 10 first, all right? Because we want to get down to x by itself. Now, notice something else that I hope everyone's thinking about there. Think. we've got a negative 2 attached to that x. That tells me inequality is going to shift somewhere down the road on this one. So let's take this thing one step at a time, like we like to say here. Let's subtract 10 and do that to both sides. Everybody got it? Everybody going there? And we're going to take a negative 2/3 x. There we go. And this is going away. All right. And this one over here is going to give us a 6. And at this point, we've got a couple of options. Remember, if you've got a fraction attached to the x, usually we remove it by multiplying by the reciprocal. Now, some of you may say, well, could we just multiply by 3? We could do that. We do that. It's going to still work the same way. I'm just going to shorten our steps here a little bit. So let's go ahead and multiply in by the reciprocal, which, by the way, is a negative 3/2. All right? Remember, reciprocals have to have the same signs. If that had been positive, we'd have a positive here. But it's negative, so guess what? We got a negative there, right? We got it. Now, remember to do the same thing. Don't leave out the right side. Good old multiplication property of inequality. And things happen. Things are going to happen when we multiply this out. First of all, this is all going positive. It's going to be x. And over here, this is going to all go negative. Let's put a 1 under that 6. And there we go. 2 goes into 6, gives me 3, and that gives me a negative 9. Oh, y'all believe me? I'll show you. How about it? There we go. 3 times 3 gives me negative 9. And like I said, we have multiplied through by a negative, so we've got to shift that direction. We've got to shift that direction. So here's the game plan. Here's the game plan. We are going to put in, somewhere on this curve, we're going to put a negative 9 on this line. It's not a curve, is it? It's a line. And we're going to put our negative 9 there. And according to this, we're going to shade to the left. To the left. Now, I'm going to pick a number. I'm going to pick a number. You say, well, can you pick any number? I sure could. But I want to pick something that's going to divide into 3 evenly, so this works a little bit easier to check. So let's go with negative 12. And you know, if I take a negative 2 times a negative 12, I get 24. And 24 divided by 3 is 8. 8 plus 10 is 18. And folks, that's greater than 16. So my solution, once again, it checks out. It checks out for us. All right. So we got everything going in the right direction. And again, that's the way you do it. Check it at the end. Just pick a point, and in that case, you wanted something that was divisible by 3. All right? Hey, just what we've been waiting for. Let's look at our next one here. We finally have that less than or equal to. Yay! I've been waiting for that. I knew I'd put one of these in here somewhere. All right, let's see what happens. Go ahead and write this problem down. Let's rewrite. We got 4y, negative 4y, by the way, that's important, plus our 5, which is going to be greater than or equal to this negative 11. All right? Now, game plan, just like we always have. This time the y is on the left, which is good news. The x was there too. And it's a different variable. And we're going to deal with this less than or equal to, but that's all right. That's going to be how we graph in the end. So you just keep with me here, all right? So let's see. We're going to subtract the 5 first. Go for that. Everybody going with me there? Take that minus 5. Subtraction property of inequality this time. All right, we're going to do that to both sides of the inequality. We have negative 4y left over. We have negative 16 on the right. And folks, we are still at less than. You say, Ernie, you got a bunch of negatives there. We haven't done anything with the division part yet. All right, we have to divide or multiply before we can do a shift here. So don't get crazy on me yet. All right, just because you see a bunch of negatives here does not mean it's time to shift. When we divide by that negative, that's when it's going to be time to shift. So let's do it. Divide by negative 4, both sides. Everybody there? Everybody good? Everybody got it? And you go positive. My gosh, everything goes positive. You got a y. We have a 4. No negative signs. And guess what happens? That less than has got to shift, and it's going to become greater than or equal to. So let's spot a 4 on here somewhere. How about it? Right there looks good. I'll put a 4 right there above it. And we're going to, this time, what's the difference? Because it has an equals to. What do? Y'all got it? Going to fill it in. Fill in the circle, exactly. So here we go. That's the first thing we want to do. Make sure we fill that circle in. Boy, that was a filled-in circle if I ever saw one. Woo! And then we're going to say it's greater than. So we're going to shade to the right. To the right. Now, you know what we're going to do. We're going to check. Let's put in a number. Well, 4, we know 4 is going to work. We put a 4 in here, we get negative 11 on both sides. All right? But let's go with a number that's greater. Let's look at 5. 5 will go in there pretty nicely. Put a 5 in there. Negative 4 times 5 is negative 20. Add 5, you get negative 15. Now here's the question. Is negative 15 less than or equal to negative 11? Yes, it is. So you know what? We have shifted correctly. We've shaded right. All is good. All is right with the world on this problem. And I hope you got the same answers that I did, all right? Working through it. We're going to do a little practice now, okay? Let's just do some practice here. And got another one here coming up. I got to put my number line edges here. All right, there we go. They look good. This time, notice what happened. I put the old X back on the right-hand side. Just to give you practice, folks, just to give you practice. It's not anything major one way or the other. It just, hopefully, if we do enough of them, you go like, oh yeah, I know how to deal with that. I know how to deal with that. It's easy. It's easy. It really is. So let's see. Again, we're back to a less than, so we've gotten away from that. You know, remember we said not all things in mathematics are created equal. Well, we're doing inequalities all day long here today, so guess what? Very few things are going to be of equals here, all right? So let's see what we do. Let's see where we're going on this. First of all, I take a look at this, and I think, it would be good if I could get x by itself. Before we try to do anything, let's just do that. Let's just get x by itself like we normally do. So we're going to subtract off 7 here and here. Take 7 off both sides. And remember, subtraction does not shift the inequality. It's multiplication and division where we worry about making this shift from less than to greater than. So leave it alone right now. Just leave it alone. And that's going to give us a big old 14 on the left-hand side. And we've got less than coming here. And then we got 4x. All of a sudden, it looks pretty easy, except some of you go like, oh, Ernie, that doesn't go in there evenly. That's okay. It does go evenly. It just has a fraction attached to it, all right? So let's see. We put a 4 under both sides. 14 divided by 4. Now, if that had been a 12, you would have gotten 3. If that had been a 16, you would have had 4. This is right smack in the middle. So guess what? You're going to get 3 and 1/2. Now, for those of you who like decimals, 3 and 5/10 will work fine also. Now, let's just translate what this should look like. This should be x greater than 3 and 1/2. All right? So up here on the number line, let's just find it. There we go. And for those of you who love decimals, I'm going to give you 3 and 5/10. How's that, okay? It's the same story, same story. Now, open circle. Open that circle there at this point, all right? And which way are we going to shade, my friends? It looks like we're going for the greater than here. And notice what happened. I had to shift just because I moved the x to the other side of the inequality. So in order to keep it truly working, we have to do this little shift, all right? So let's go to the right. Shade to the right. And there it goes, there it goes. Darken up that edge. And you know what's going to happen. I want to make sure we got the right thing. Do we do the right thing? First of all, if I look at 3.5, well, I don't want it, do I? Because I've got an open circle sitting there. So we're going to leave that going. But let's see what happens if I put the next integer over. They're easier. They are. Let's put in a 4. All right, so if we put a 4 here, remember we do multiplication before we do addition. So 4 times 4 gives us 16. Add that 7, add the 7 right there. You're going to have 23. Is 21 less than 23? Yes, it is. Yes, it is. So we've shaded the right direction. We found where we need to be at 3.5 or 3 and 5/10 or 3.5. Different ways you can write it. But the idea is that we should end up shading it off to the right. Off to the right. Okay? So there you have another good example. And I hope that one came easy for all of you guys. Even with the little shift at the end, you were okay. You did well. You did well. Speaking of doing well, let's take a look at our next one here. Next one. It says solve the inequality and graph the solution on the number line. You know, I want to make that number line look like a number line, so let's do it. Right, there we go. We'll come back and visit it in just a little bit, all right? Now, I've got a 7, I've got a minus 4x. And I want to get x by itself. So this is one where we got to be, just take it step by step. Don't jump the gun. Don't get out of whack. All that good stuff. Let's work with this 7 first. Now, by the way, that 7 is positive. Everybody see that's positive? That minus goes with the 4. Okay, so that's going to make a negative 4x here in just a second. All right. So let us do it. Let's subtract 7. And we'll subtract 7 over here. Again, using those inequality properties. This one is the subtraction property. And we are going to get 24, I believe, unless I mis-subtracted on that. Like I said, today I was promising you we weren't going to have to go to the calculator very often, and now, so far we haven't had to. The 7's cancel, and I've got minus 4x sitting there looking at me. Now, folks, we haven't shifted anything. We are still at greater than. We're still at greater than. Subtracting 7's have no bearing on the inequalities, whether it's less than or greater than. Has no change for that. It's when we deal with this little guy here, this -4 that we're going to have to divide by. That's when the fun happens, okay? That's when things move around. That's where you got to be alert. Got to be alert. So let's do it. We're going to subtract. No, we're going to divide, right? We're going to divide by -4. And here we go. We're going to take -4 over here and divide it into that 24. Now, remember what I said? When we divide by negatives, the signs change. So you got to watch for that. That's going to give us a -6 over here. Well, it's going to give us positive x over here because those are gone. Those are gone. Signs have changed. Everything's good. But in between, when the signs change, so does the inequality. It shifts. It shifts. So here we go. So now it looks like it says -6 less than x. All right? So let's go with it. You know what's going to happen. We're going to switch it so we don't mess up on our graphing. Here we go. We're going to say x is greater than -6. So find -6 on your number line. Looks like a good as place as any. Again, we're going with open circles. Looks like I got carried away on open circles today. Sorry about that, guys. And I'm shading to the right because it's greater than. All right? So let's shade to the right, to the right. And let's hope that's right. Correct, that means. All right, let's use it here. Let's see what we got. How about any point greater than -6? How about it? Let's just throw -5 in there. Let's go to the -5. If you put a -5 in there and multiply it by a -4, you get a +20. Now 7 plus 20 gives you 27. All right, so we got 27 sitting here on the right. Is 31 greater than 27? It is. Yes, it is. Yes, it is. And I'll tell you something. If you go further out, let's say you go to 0. Go to 0, because 0 is to the right of -6. It's a greater than situation. If you put a 0 in there, my goodness, it's going to be 7, and over here is 31. 31 is greater than 7. It's even a stronger proof that you're on the right side of this. So, my friends, you can pick any number in the shaded region. 0 is easier. Not that 5 was anything very difficult, or -5 in this case, I'm sorry. Even a +5, wow, that would really have, would have really sent us into a true greater than situation, all right? So there's the case. That's why we proof. That's why we proof it and check it and make sure. All right, let's look at one more here, and I'm going to fix this one. We're going to have an equals to there, because I just want to see one more where we have to fill in the circle. How about it? All right, just to prove that we can do it, right? All right, so here we go. Once again, number line, it says solve the inequality and let's graph the solution on the number line. We've been doing this over and over today. And once again, let's recopy on this one. Kind of gets big. And let's see where we're going to go here. See where we're going to go here. Let you all get that copied at home. First things first, we always like to get our x's one way or the other. Let's go ahead and subtract 5x from both sides. I'm going to move them to the left side this time. All right. And I see, do y'all see? I hope we all see. I see a -3x minus 3. There's a lot of 3's popping up here, my friends. Still got a greater than. Still got a greater than or equal to. And these are gone. Got another 3. All right. And of course, Mathline, we love 3's, right? Got it. So let's see where we're going to go from here. We've got +3. We're going to get rid of that puppy. And we're going to see what we end up with here, all right? Now, notice what I did. I added 3. Folks, do not make the mistake that some of you probably just did and add -3 and 3 and get 0. All right, so let's see where we're going. We got -3x greater than or equal to 6. And what we're going to do, we're going to get our x by itself. And remember what we're doing. We're dividing by -3. Which means, yeah, you all know, it's got to shift in inequality now. So we're going to have x less than or equal to, watch your sign, -2. So let's find a -2 up here, fill it in, because it's a closed circle, because we got the equals to, and shade it. Yes, which way? To the left, this time to the left. And we'll keep it going in that direction. A quick check. I tell you what, we need to put what point that is. That's -2. Don't want to leave that out. So let's try with a -3 maybe here. Put a -3 in there because we know -2 is going to work. -2 is going to give us the, looks like a -7 on both sides. So we put a -3 in there. My goodness, I've got -9 here. And I've got, looks like a much bigger negative over here. All right. And -9 is greater than negative, what do we got, folks? How about -12 there? All right. And that would be true. So our numbers there are correct in our graph. So again, thank you for tuning in today for Specialized Segments. We will be back live again this coming Monday for you to call in and such. But in the meantime, send us emails. Check us on Facebook. Do all good things. But have a great weekend, and we'll see you next week.